Good evening, class. Now we're going to take a look at the law of sines and the law of cosines. Both of these are a little bit challenging, but the nice thing about them is that they can solve every single possible triangle. Every, not just right triangles, which is what the other ones could. This can solve any of them. So if I look at the law of sines and the law of cosines. First of all, we're going to look at the law of cosines. For any triangle, this following statement is true. Alright, so sine of A over side A. Sine of B over side B. And sine of C over side C will always have the same exact ratio, no matter what triangle I'm looking at. So, what if I was trying to solve something like this, and it said solve for all the variables? Well, let's look at the triangle I'm given. Well, I look. Well, let's set up the law of sines, see if I can do this. Sine of 35 degrees over A equals sine of 65 degrees over B, which equals sine of 80 over 7. Now, for the law of sines to work, what has to happen is one of these ratios has to be a full set of numbers. And it just so happens that the last one is. So to find one of these, I choose one of the other ratios. I chose sine of 65 over B equals sine of 80 over 7. And I'm trying to solve for B. Well, it's a proportion. Cross multiply. 7 sine of 65 degrees equals B sine of 80 degrees. Divide both sides by sine of 80 because I want to get rid of it. B equals 7 sine of 65 degrees over sine of 80 degrees. And at this point, it's a calculator problem. So, 7 sine of 65, close parenthesis, divided by sine of 80, close parenthesis, enter. I get 6.44 for B. Now for the other one, I would do the same exact thing, but now I'm plugging in sine of 35 degrees over A equals sine of 80 over 7. Cross multiply, 7 sine of 35 degrees equals A sine of 80. Divide both sides by sine of 80. So 7 sine of 35 degrees divided by sine of 80. And that should equal A. So A is, well, I plug in it into the calculator again. And I get 4.076. Sorry, 77. Yeah, law of sines works for any triangle. This is kind of neat. It doesn't have to be a right triangle anymore. In everything else in this chapter, it had to be a right triangle. It had to be a right triangle. It had to be a right triangle. And all of a sudden, you get to the law of sines and the law of cosines, and it says, hey, it'll work for any triangle. Alright, so set up your ratio. One of these have to be a full set of numbers. If it is, set up a proportion using one or two of the ratios, then set up the proportion using the other two ratios. And solve. Alright, what do we do if I'm not given one of these ratios completely? Well, if I'm not given one of the ratios completely, what happens is I have to use what's called the law of cosines. And that law of cosines is pretty nice because that allows me, for whatever three pieces of information I'm given, I can solve for the entire triangle. We're not going to do many examples of this. You only have like 5, 6, 7 problems in your book that you have to do. But it is something important. So, the law of cosines is the start of the Pythagorean theorem. C squared equals A squared plus B squared. Now, what that's saying is it doesn't matter what side you choose. You just choose one. And it's equal to the other two sides added together squared. But then what you do is you minus 2 times those other two sides multiplied together times the cosine of C. So let's just real quick look at an example of what I might mean here. Well, if I look here, if I would set up my sine ratio, I would not have a full set of numbers anywhere. But in this case, 55 degrees is here. X, Y, A, 17 and 18. I could find all the variables using the law of cosines. Well, I'd find the first one that way, and then I use the law of sines after. I look, none of the ratios work. Dang. But here's the thing. I'm going to change this A to Z, just so we get on it. The side I want to solve for should already be solved for. So in this case, if I'm looking for Z here, I'm going to plug it in for C. So Z squared equals the other two side lengths squared. So 17 and 18. 17 squared plus 18 squared. Minus 2 times those two side lengths. 2 times 17 times 18 times the cosine of the angle across from Z. 55 degrees. At this point, it's just being really careful with your calculator. Z squared equals 17 squared, 289, plus 18 squared, 324, minus 2 times 17 times 18, 612 times the cosine of 55 degrees. Add these two together, Z squared equals 289 plus 324. 613 minus 612, cosine of 55 degrees. And at this point, I just carefully entered in my calculator. Z squared equals minus 612 times the cosine of 55, close parenthesis, 261.97. Take the square root. Z equals 16.18. I was able to find the last side using the law of cosines. Wow. Alright, let's find the other two angles. So this is 16.1855. So let's use the law of sines over here. Sine of 55 degrees to 16.1855 equals sine of x to 18, which equals sine of y to 17. Now I have this ratio work, so I'm going to use it. Sine of 55 to 16.1855 equals sine of x to 18. Cross multiply. 18 sine of 55 degrees equals 16.1855 times the sine of x. Divide both sides by 16.1855. 18 sine of 55 divided by 16.1855. Sine inverse both sides, get rid of the sine. And this is why I don't have a practice this one too much, but 18 sine 55 over 16.1855. Basically, if you give me your best attempt in this section, even if you don't get it right, that's fine. It's an extension, something extra. You'll learn it next year, so you'll get it then. However, I thought I'd include it here just because it was a nice addition at this point. And then very carefully plug this into your calculator. If you do this correctly, I believe you get x to be 65.64 degrees. So let's see, x is 65.64 degrees. And at this point, I would say use the law of sines again, but that's a lot of work. So at this point, I would say, why don't you just use the idea that all the angles of a triangle add up to 180? Because at this point, you can. Y plus 65.64 plus 55 equals 180. Y plus 120.6 equals 180. Y equals 59.4, so 59.4. And just as a real quick check here, does the longest side end up being across from the largest angle? Does the shortest side end up being across from the shortest angle? Awesome. And there you go. This is the law of sines, law of cosines in a nutshell. It's pretty tough. Yeah, it can be a lot of work, but you can find all the information of a triangle real quickly, like that, by hand. Well, besides using calculator for cosine and sine. But there you go. That's everything I have for you for the section. You should now be ready for the test. You won't be seeing any examples of this on the test, but you still should attempt the homework. Again, I'm looking for best effort. That's all. Till next time.